Hi everyone. Hi. How are you doing?
Good.
Good.
Did you see the solar flare yesterday?
Oh no, I did not. I did not.
I believe that it's gonna be there today as well. I don't know. It might have already been past
Okay,
sunset in Toronto.
I see. This is 10:30 p.m.
Yeah. So yeah, maybe you missed it. Maybe after midnight you might see. I saw it
Oh,
yesterday after midnight.
oh, oh, oh. Where are you located? In
Vancouver,
the Vancouver. You are in PST. Okay.
PST.
Okay. Now,
Yeah. I mean, after my end of day, nobody works. PST.
I see. Okay. Wonderful. Let me see.
One question. So I was looking at the link which you sent on WhatsApp for yesterday's Zoom meeting, right? It's asking for participation code. I gave the one which was shared, but it doesn't work. So I'm not sure if I'm missing
I
out something there.
did not see that message. Let me see if I can just okay. Thank you for letting me know. Okay.
I believe this case is only for Saturday lectures because otherwise Sunday lectures are available for next Saturday. But the Saturday
No,
lecture, right? If you
it's
miss it, then you
basically,
don't get it.
yeah. Basically, since it has to be downloaded and all, I did not have time, so I basically just did it quickly. Okay. So let me see. Okay. Everyone with the recording link. Okay. Let me see. Good. Okay. I think it's the same link. Okay. Yeah, I've shared with the passcode. Okay. It's good that I have never done it before, so it's good that you let me know. And it's Zoom gateway, Zoom gateway, Zoom gateway, Zoom gateway, Zoom gateway. I'm not able to find the other ones. I've messaged now.
Yeah, got it. Thanks.
Perfect. I think the other people would also be facing the same problem. I will fix that thing also just after the meeting. All right, everyone, please feel free to keep your cameras on. And I mean, please keep your cameras on. Okay, it's a good thing. So my humble request. Thank you, Disha. Thank you so much. Thank you so much, Ree. Really appreciate it. Thank you, Veena, so much. Everyone, please keep your cameras on. It's a good idea. Okay. Thank you, Sanish. Thank you, Abhijit. Really appreciate it. All right. Wonderful. Wonderful. Perfect. Perfect. And there we go. All right. Before we start, do you have questions for me? Okay. We're going slow, and I think this is a good time to cement the foundation into the Python one. Specifically, core idea will be that we learn how to convert a thought into code. Okay, that is the main purpose of this part. Okay, our purpose or agenda is not memorizing any of the Python constructs. Our agenda is not about idiosyncrasies of Python. We are not going to become expert at Python. Our agenda is to be able to convert a problem or solution to a problem into code. Okay. If you understand, or if you, let's say, memorized all functions in Python, a string library, you have like knowledge of everything. But if you do not know how to solve a particular problem or code or create code, that means you have not learned it. Okay. It means that you have not learned programming. The whole purpose is defeated. Okay. So whatever it takes to get all of you into this habit of writing code, being able to create code, given a problem statement, that is the main agenda. Okay. And as soon as we are done with arrays and loops and all of that, I'm going to jump right into, problem solving. Okay. So as soon as we finish loops, I would straight away jump into loops and functions, two things. And that's it. And I'm going to jump right into, solving problems. Okay. The rest of the things, object-oriented programming, this, that, all of that is easy. Hard thing is converting a thought into code. Okay. Like saying, for example, let's take a case. Let me give you guys a quick challenge. Okay. Let me give you guys a quick challenge. Okay. Right. Feel free to make a note of it. Okay, I'll actually just create a notebook and we'll share the notebook at the end. I will also inform my teammates to to upload this in the LMS. But for time being, because they don't work on Saturday, Sunday. They only work on weekdays. So I would okay, now, right? This is the notebook. Okay, here's a simple question. Okay. Print all names that can be print all strings that can be generated from a list of letters. Okay. For example, if the input is A, B, C, the expected output is A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. Did I miss anything? All right. So this is for later. I think this is just to make sure that you are all on the same page. Just want to make sure that you understand what it means by coding. Okay, you understand what it means by coding, and okay, now moving on. So this is for later, not now. Okay, this is for later, not now. So now we are moving to a very important topic called conditional execution. Okay, some of the things might look from a previous version of Python, but I'll correct those as we go. All right. So yes. So yesterday we talked about variables and statements and so on. Okay, the expressions and so on. We talked about very basics. Okay. Now, all right. Did anybody solve the problem I gave yesterday? I gave two problems. One was to calculate the salary. Calculate the total amount of salary payment if you are given per hour charges and hours, and you have to take the input. And second problem statement was to compute the interest rate. Correct? Those were the two problem statements. Now, all right. Now we will also focus a lot on more things as we go ahead. Okay. So conditional statements are pretty simple, very, very simple. Let's say we have this program. I think I'll just do it right away. Okay. I think the way I would do is I'll just write the code. Okay. Because Python, you can just write code. Okay. So in case of Python, right? Let's say there is a number x equals 12. You can say if x is equals to 12, print yes, it is 12. Okay. Else is not needed, by the way. Okay. So you can see that it is 12, right? If it was, let's say, 13, then this would return nothing. Okay. So basically here, rather than in normal Python program, if you just put things, right, if you just put statements like this, they will execute all of them one at a time. Correct? They'll just run one at a time. First this, then this, then this. But if you do put if condition, so if followed by a condition. So x equals 12 returns true. And therefore, this if condition gets executed, anything which is within this tab, you see how it detects that what is inside inside the block using this tab space. Okay. Now, you're using this space. Now, if you, let's say, put more things into it, let's say you put here, all right. I'm just putting all right. Okay. So this got executed inside, even if it was inside. You see that? So it is thinking that this statement is inside the block, correct? Because it has the same indentation, correct? Now, if you put it outside, let's say in this case, okay? Okay. Let's say I'm here typing I'm done. So what will this print, everyone? Okay.
I'm done.
This print I'm done.
Yeah. So you can see that This thing is inside the if condition, which is false. This returns false, correct? And therefore it doesn't go into this. So if false, then, right? So since it's false, so it doesn't execute. If it was true, then it would have executed, correct? And is everybody okay what's going on here? Yeah, feel free to stop me here in case you are not clear. Is everybody okay? So this thing is outside the block. The I am print, I am done, the line number 5 is outside the if block, so that even if it doesn't enter here, this will always run. Whether it goes in or out, it will always run. Let's say it was 12 here. It'll say, yes, it is 12. All right, I am done. Okay. And whether this condition is true or false, irrespective of that, this will run. Are you guys okay? So I talked about two things. One is if condition. You see colon here? Colon, right? So a very good important thing to do right now would be that all of you should, code it up, okay? If space followed by a condition, colon, followed by a tab, then the statement, then the tab, other statement, and so on. And once you're done, you can just print this, okay? Now, very important part is that you can keep as many nested statement as you want, okay? So you can say, all right, let's say you are trying to figure out if a number is divisible by 5 or 4. Okay, let's say I'm leap year. Can somebody tell me how to define a leap year? Okay, so if year divisible by
4.
4, okay, right? And then what is the logic behind leap year?
If year
Four.
divisible by 4, then it will be leap year. Otherwise, it will not be.
No, there is 100 rule, right? Leap
Yes,
year.
yes.
Okay, a year occurring every 4 years. Okay, every 4 years. Okay, and okay, what is a simple definition of a leap year? Okay, okay, the year must be divisible by 4. Okay, except for end of century years. Okay, the year must be divisible by 4, except this means that year 2000 was a leap year, while 1900 is not a leap year. Okay, so okay, so which means that let me see. Okay, who will help me in this code?
It should be divisible by 4 or 400 will do that.
Okay, if year is divisible by 4, okay, and if year is divisible by 100, okay, okay, and okay, let's see. If year is divisible by 100, okay, then what do you do? Okay, if year is divisible by 100, we check if year is divisible by 4 or not. Sorry. Okay, how do you check something is divisible by 100? We say year percentage 100, 0. Okay, then in that case, we check if the year is divisible by 400. Okay, I'm just writing a clumsy code. It is a leap year. Okay. Now you'll say if year is okay. Now you can say here, all right. You can say now. You can also say if year is divisible by 4, okay, else, okay, if year is divisible by 4, print it is leap year, okay, else print okay, all right. That suddenly became complicated. Print. Okay. Now, so 2004 is a leap year. 1900 is not a leap year, right? And year 2000 is a leap year. Is this logic okay? So we are saying if the year is divisible by 100, what does it mean? Let's see. Okay. Let's break it down. So this one computes the remainder. If the year is, let's say this one gives 88. Got it? So it says that, okay, it is basically not divisible by 100. Okay. So because here we have said, if you say here, okay, so you can see is divisible by, it can be written like this. So if the year is divisible by 100, year %100 equals 0. Correct? Is everybody on the same page with me? Is this logic clear? If you want to check if the year is divisible by 4, we can just do this. So this is divisible by 4. Okay. We compute the remainder using %sign, and then we compare it with 0. That's how you check the divisibility. Okay. So we are checking here. First, we are saying check if the year is divisible by 100. If the year is divisible by 100, then we go in and check if the year is divisible by 400. Okay.
Sandeep, I mean, line
Yes.
number 2 and 3, right? If you just in line number 2, if you say the year is divisible by 400,
Yes.
and then say it is leap year, you don't have to write 5 and 6, right?
Okay. Yeah, but we can't test the other parts. Okay. So I just wanted to, that's a brilliant idea, and that's what I'm going to do next.
Okay.
Yeah, that's what I'm going to do next. And yeah, let's try to, another very important characteristic is to, where important thing to do is reduce the number of lines in your code. Okay. Usually that improves a lot of, readability in your code. Okay. So what is happening here? Okay, good. So I'm going to say, so somebody has, Rahul has posted his logic. Okay. Now, yes, this is correct. This is correct. Okay, now this is very good. Now let's move on, and I'll show you something. Let's take a look at this one. So here, there are multiple things that I tried to show you in a single piece of code. Number one, you can have if and else. Okay, if this is true, then do all of this. Okay, you see the whole block? The block is marked by the indentation, right? This space, all of this space has to be same. Now, you see this one is inside the block of if, okay? And this whole thing is inside the if. So you can keep blocks within blocks within blocks. It is up to you, okay? Here, this one is essentially saying, if this is this condition is true, then do all of this. Otherwise, if this condition is not true, it would do this. Okay? And then inside it, again, the same rule applies. Is everybody okay with this long code? We checked if this thing is divisible by 100. If it is divisible by 100, it has to be divisible by 400. Otherwise, yes. Okay? Okay, is everybody good with this? Are you clear about this piece of code? Some of you have better code. Some of you have written better code. I will address that. Okay. So you can have if and else nested to any level. There is no limit to it. Okay. But this is an ugly code. Okay. Why it's an ugly code? There are just too many lines. You could write it in a single statement like this code. Okay. Here, the code says if year %4 equals 0. That means if year is divisible by 4 and year is not divisible by 100. Okay. So you see the AND operation here? AND operation is quite an interesting one. So like, for example, if I say 1 equals to 2, okay, that's false. If I say 1 equals to 1, this is true. I can say and 2 equals 2. So this and this. Okay, so these two conditions are ANDed, and that's how it is. Okay. All right. I hope it makes sense to you. So here we are saying if year is divisible by 4, okay, and year is not divisible by 100. You see, not equal to, this is not equal to. Okay, so year is not divisible by 100. It means, how am I writing? First, we computed the remainder, and then we checked if it is not 0. Okay, that means it is not divisible. Okay, so we are saying year is divisible by 4, and year is not divisible by 100. Okay, right? If this is true, that means that if this whole thing is true, that means the number is, the year is a leap year, correct? Otherwise, okay, just check. If this is false, if this condition turns out to be false, it will go to the OR and it will check if the number is divisible by 400, right? So in plain English, it is if year is divisible by 4 and not 100, okay, and not divisible by 100, okay, this is one condition, okay, and we are saying or year is divisible by 4. Okay? Are you guys clear about this? Is this condition clear to all?
Yes, sir.
Yes, sir.
Perfect. Very happy. Okay. Any other questions at this point, everyone? Feel free to ask, okay? This is extremely important. I want everybody to, be very comfortable with the code.
Only that is considered as indentation or
Yeah.
spaces and
Can you come again, Madhumita?
No, only tabs are considered as indentation or spaces are also.
Good question. Good question. It could be anything, okay? It could be anything. Let's just test it out. If true, okay? Instead of tab, I'm going to place two spaces. Two spaces, okay? It should ideally work, okay? Whatever spaces you put once, that's the same spaces you have to follow, okay? Like, for example, I said two spaces here, okay? And I ended up putting three spaces now, okay? It will throw an exception, okay? So basically, any number of spaces is good, okay? Try using more than one space. I prefer the 4 spaces. 1, 2, 3, and 4. I prefer the 4 spaces, so I think 4 spaces are good, though it is okay with single space, 2 spaces, 3 spaces, 4 spaces, 5 spaces, as long as you are consistent with the space. Whatever space you have put in the first indentation, that's the same thing that you have to follow. For example, if I do 5 spaces here, it will work. But if you do 4 and 5, that becomes messy here, okay? I mean, when it goes into, let's say, here, then it might throw an error, okay? So be very consistent with the spaces, okay? And as a thumb rule, as a good practice, what you should do always is have in your text editor, go to the settings, make tab automatically be replaced with 4 spaces, okay? Make it replaced with 4 spaces, okay? And every text editor has this thing, okay? Very good question. All right, anything else before we move forward?
Sandeep, I have a doubt. If a year is 240, then the program will be like say false, na? Because it's divisible by 100.
Okay, let's see. With this one, right?
Yes.
2040, correct?
20240.
Yeah. So see, year is divisible by 4, that's true. But this
Correct.
is also true because the year is not divisible by 100. So this whole condition is true. So year is divisible by 4 and year is not divisible by 100.
Correct. Yeah.
And that's what it is. Make sense now? Yeah. So it seems okay to me. It's okay to me. So see, here we are saying year is divisible by 4, okay? And year is not divisible by 100. So both conditions are being satisfied with 240. That means this whole thing is true. Then we are saying, if this was not true, then it will go and check the OR condition. Okay, because in case of OR, either this is true or that is true. If this turns out to be true, then this won't be executed. This won't be executed.
Okay. Getting.
All right, perfect. Very good question. Moving on. I think you should always poke holes like Sneha. that you should run down with different examples and check whether your code is correct or not. And specifically, the corner cases you should work upon. Okay.
We have
Now,
an elif statement also, right? Not only if and else.
so let's say you want to check things like if let's say whatever is the month, you have to print the days. Okay. Month equals to, okay. Give me a good problem to do if else condition. Okay. Let's say, okay. Let's say we are saying, okay. Let's say year is equal to 2004. Okay. Month is equal to, say January. And our task is to print this, the following code prints number of days. Okay. Let's say you want to write this logic. Okay. Number of days in that month. Days in the month and year. So you are given year and month, and now you want to print how many days are there in that year. Okay. So you'll say if month in, you will write an array. You'll say month in Jan, March, April, May, June, July, January, February, March, April, May, June, July, August, September, August, September, October. Okay. If month is in there,
Instead of November, it should be December, right?
oh yeah, thank you. December, right? So you'll say print how many days? 31, right? Okay. Now, so it is working fine. Okay. Now we are saying elif month equals February. Okay. Now you're saying here, you will check if the, now I'll take this condition from here. Right? I just copy pasted that condition, and I'm saying if the year is divisible by 4 and year is not divisible by 100, okay, so what is the number of days in February? Okay, so is this correct? In the leap year, it is 28 days, 29 days. Okay. A year
29
occurring
days in leap year.
every 4 years. 29. Okay. Now, right? So do you think this logic is right? So here we say if month is in this list, that means print 31. Elif, notice elif, okay, elif, meaning else if, combined together, elif. And then we are saying month is equal to February, then do this, okay? So we are saying that if the month is February, then do this. Otherwise, for everything else, print 31. That's about it. Would somebody like to poke holes? Let's take a look. So I want to find out how many months are there in the, January, the February. Okay. All right. Am I making sense to you? No.
Sandeep, instead of taking the hard-coded month names, could we take something like a month function? Because the month name could differ as input whenever if someone is inputting. Since instead of February, someone is typing Feb. So that those things
Yes.
we'll have to take care when we are hard coding.
Exactly. Okay, so that's a very important question. Imagine that you were saying taking the input. Okay, input as here, say which, okay, which month, okay, and we are saying which year. Okay, so you are asking here. Okay, sorry. I'm just writing here. All right. Okay. So here the problem is that what if somebody does a I mean, somebody writes something wrong. Okay. So I'm saying for year 2024, for the month of say Feb. Okay. So I wrote a small case and then I said, convert it into this. Okay. Now, do you see what I'm doing, everyone? So I read the year as an input from the user and then converted that into integer. Then I read the month from the user, which is anyway the string. I am asking explicitly only enter 3 letters, and then I'm capitalizing it because I, by mistake, capitalized these. Ideally, I would have just kept it uppercase. That would have been easy for me. But for now, just to check this. Okay. Are you guys okay? Is this what you meant? That the month entry might be in the form, maybe mistake. So yes.
Yeah, this also I meant, and other than that, what if we do not define the three-letter input? Then the user enters the full name of the month. Is there a way we can convert the input into integer instead of the name? Say February would be 2, January would be 1, July would be 7.
Yeah,
And in
yeah,
our if statements, we'll just check the divisibility and according to that.
yeah. So you can do all sorts of things here. You can check if month is okay. Okay. Is how should I do? What should I do? What should I do? Okay. Okay. If I'm just thinking louder, if month greater than, okay, this is something, the hard exercise. I'm just trying to see if, let's say, length of month is greater than 2, then first convert that into uppercase. Otherwise, try this. Okay. Or a thing you could do is, I'm trying to see if, let's say, somebody, yeah, because there are two cases, right? Yeah. And then I'm saying here, whatever month the user has entered, okay, if the length of that one is greater than 2, I'm picking, after capitalizing, I'm picking first 3 letters. Okay. And then if this is not greater than 2, it is say, right, it is equal to 2 or equal to 1 length, what I will do, I will say integer and say month, okay, and then I would print, okay, and that's about it, okay. Now, if I say year is 2003 and I am entering say 2, okay, then basically that will become a trouble here, okay. So in this case, what would I do? What would I do? In this case, I'll have to come up with something else, okay. I'll have to translate, how should I translate? I'll have to translate month equals to, okay. I will, let's say I wrote all these months here, okay. I wrote these months, January, February. I'm super lazy, but you are making me do it. Okay. April, May, June. Okay. I would have done it your way. July, August, September. November. Okay, so here we are, and I'm saying pick. All right, and that's it. Okay, so here you can further debug your code, show the month. All right, so what did I do here? Yeah, slowly things have become complex. But one part is error handling. Other part is taking the input, handling the error, and dealing with the error. And the second part is picking months. And then third part is here the leap year problem. Okay. So can anybody wants to walk through this code? Who can walk through this code? Please raise your hand. Yeah. Ranveer, do you want to walk through this code?
So Sandeep, what does it mean by month dot capitalize 3?
Yes. Okay. Month dot capitalize 3. It means
On 3 character only, right?
yeah, somebody wrote February. Okay.
Mm-hmm.
And it'll first do capitalize.
Right.
Okay. So F became capital and say colon 3. Okay. So I'm saying here, remember the array notation from beginning till third index, except for the third index. So first 3 letters, 0, 1, 2. So up to the second index.
Okay. So in capitalize function, it will only make a first character as an upper. But if we'll use dot upper, then it will make everything uppercase. That's the difference between capitalize and upper.
Exactly. You can see that. Okay. That's right.
Okay.
Okay. Yeah. All right. You want to walk through the code?
Sure. So I think first we are getting the input, right? That's where we are using the input function. And then user will enter the year. The second would be we are taking the month. But
yes. And this one, what is it?
This is an integer number.
It is converting the year into
integer. Yeah.
Perfect. Okay.
And then this is the input for the month, or what we are entering, and then we are running certain condition for the month, right? So that's where we're just counting the length, because length is the function for counting the length, which is greater than 2 as per your condition. And then it will capitalize another function for which we are capitalizing, and thus taking the 3 character.
Yes. So if the length of month is more than 2 characters, I am guessing that it would be this. Okay.
Right. Otherwise, it will go to the else condition.
Yes.
Right. And that's where, you know, be trying to, you know, keep the month as an integer, right? 1, 2, 3, and then it's comparing with your condition, you know, like 2, 3, whatever, Jan, Feb, March, and accordingly be printing that month, you know, in your print conditions.
Yeah.
Right. So that's what the first if else condition.
First if else condition is just converting whatever you are entering into this. Of course, it's not future proof. Let's say I can enter, let's say 2004, and I can say XYZ, will print 30 because it'll go into else. Okay.
Yeah.
So we might have to come up with something else. Yeah, go ahead.
And then I think after printing month and year, then we going the leap year, you know, conditions, whether it's a, you know, leap year or not, that's what we are printing in the next LF conditions and all.
Exactly. Further, let's say we realize that there is one bug, like if somebody enters XYZ, it's a 3-letter word, and it is considering it to be 30 days, right? We can do some more magic in there. What you can do here, first thing you can do is here, we will say Alif, okay, month in, okay. I am going to make a little bit of correction to what I was doing.
Okay. Because Sandeep, one more just point. So what does it mean by month -1?
Yes. So see, month here we are asking for, if somebody says 1, that means January, correct? But here the index is 0 of this one.
Okay.
So whatever, if you enter 1, it will subtract 1 from it.
Right.
Okay? Will become 0. Let's say you want to take a look at 3rd March, right? So a user entered 3 here. So, and what is the index of this one? 0, 1, 2, right? That's why I'm saying 3 minus 1. Okay. If you don't subtract, so we are picking that particular month based from the index of this one. If you see, let's say here, let me just take this. Okay. Months equals to this, and I'm saying months, give me first month. So first month is not January, it's February. Okay. Second month is March.
Month is character field, and we're trying to convert it into it, so it can be converted into ASCII. Or can you try to execute, or I may be not able to understand?
This one. No, I am saying that you are allowed to enter an integer number. Okay. Like, for example, I am saying this is the year, and I am saying my month is 6. Okay. Now it'll read it as a 6, and then it'll come here. So if length of month is greater than 2, then it'll go here, but it is less than 2. So it'll go to this loop, this else condition. And then what will it do? Convert this string to month. So this month will be 6. This month will be 6 because I entered 6 number. Now what I'm doing? I am from this big list of all the names of the months, I am picking the 6th element. Okay. Now, sixth month, right? This is first month, second month, third month, fourth month, fifth month, and 6th month. The only problem is in Python, since the list starts from 0, so we have to subtract 1 from it, and only then we will pick that one. Let's say somebody entered 6, so we have to go and pick which one, June month, right? Which is 0, 1, 2, 3, 4, 5. So June month is actually at the index 5th. So we'll have to convert let's say we will have to say index equals to month minus 1, and we basically pick the value at the index.
Yeah.
Make sense?
Got it.
Sandeep, why do we need that condition? Length of month equals as 2. What actually it is doing?
Basically, I am just defending against the problem that maybe somebody entered just the integer. Okay. Of course, there is one big problem here, that what if a person enters an invalid, say 3000. Okay. And that, right, that becomes a problem. So I'm assuming that people will either enter a month like a integer, or they will enter a month like a string. Okay. If they enter a month like a string, so I will capitalize it and just pick 3 characters from it. Okay. If they enter the month like an integer, I would basically check the length, and is this less than two characters or so? Because if they're entering as integer, what's the longest number it can go to? 12. Okay. And I'm saying just pick the, right, just check the length. In case it is greater than 2, then go for assume. Okay. So it must be a, it must be in MMM format. Okay. Like the name. Okay. Otherwise, it must be a number. Okay. Like 3 or 4 or 8 or 12. Correct?
So it will come into picture only when the input is a string, right? For integer, it will go to the else condition.
Yes, yes. I'm saying if the total number of character user has entered is greater than 2, it will go here. Otherwise, it will come here. Got it?
Okay.
Sandeep, in line number 14, you have mentioned the index. What does a list followed by that variable imply?
So I'm picking from, this is a number, right? So
Yeah.
basically I'm saying if the user entered a number as a month, okay, convert this month into a name.
Yeah,
Convert this.
I got that part, but just a list followed by an index. What does that mean? In this context, I got.
Same as this, right? List, this is my list. Okay,
Yeah.
I'm calling months. And if I say give me 0, it gives me 0. Okay. Coming somewhere, I'll say kernel entry. Okay. So let me show you. Right? So months 0 is this. Okay. Same thing, instead of writing in a second line, I could also do it here. Okay.
Okay.
So I can say something like this, right? I could say this. Correct?
Got it. Yeah.
All right. Okay. So is everybody okay, or does it look too muddled? Okay. Let me fix the problem. Okay. There was another problem with it. If somebody enters XYG, which is 3-letter word, it was coming to it was checking if the month is in this, that is false. If the month is equal to February, that was false. And then we were just printing else. So I'm just trying to fix that problem by introducing explicitly here. So I'm just checking if the month is in Jan, March, May, July, August, October, December, then do this. Okay. Else if month is, okay, let me say, okay. All right. Okay. We can do one more thing. Okay. I will call it all months. Okay. I'm defining an array at the top called all underscore months equals this. Okay. The other constant I'm defining is this one. Okay. It's called big months. Okay. I'm just writing them big months. Okay. Big months. And here I'm saying big months. Okay. So let me see if I can do this. Okay. All right. Here, the first thing I can do is if month not in all months, all underscore months, print invalid month. Else if this, okay. So let's say now I'm saying 2004 and I'm typing XYZ, okay. It says invalid month. Make sense, everyone? So again, let's walk through the code, right? First of all, I defined these two variables called all months and big months. Okay, these are all months in a year. And these are big months, which is 31 days months. Okay, then I am taking the input from the user called year. This is an integer. This is a string. Then I'm checking if the length of the month, this is a string, the length of this month's string is greater than 2. Okay, then I am picking first 3 letters. Okay, and capitalizing it, meaning first letter uppercase and every letter lowercase. Then I'm saying else, if let's say it is lesser than or equal to two letters, in that case, I'm trying to convert it into a month. Okay. Now, the problem would be if somebody says JA instead of Jan, JA, that's a 2-letter one, then this will fail here. Okay. I'll talk about how do you handle that later. Okay. So we can here check if the month is made up of a string. Okay. We can also, there is something called try. Okay. And we could say except. Okay. Just for time being, I'm going to say, okay. So here, invalid month number error. Okay. So I have put one more extra thing. Then I'm moving on. I'm saying print month this much just for debugging purposes. And here I'm also, what I'm doing is I'm picking from all months, okay, at this particular index because we assume that user has entered the numeric month rather than a text month. Okay. And then I'm picking that particular month from this all months. Okay. So now the month is a proper capitalized 3-letter string at this point of time. Okay. Okay. Here, by this time, the month must be a 3-letter capitalized. Okay. Capitalized, right? So, and then I'm checking if the month is not in all months, okay, then we are saying invalid month. If the month is part of the big months, then we are printing 31. If month is a February, then we are checking if the month is a year is a leap year. In case it's a leap year, we are printing 29. In case of non-leap year, I'm printing 28. Otherwise, I'm printing 30. Okay. Are you guys with me? See, type checks is not really that easy. Type checks, because you have to try converting it into, right? You can see invalid month number error. Okay, so I have said try except. In case this happens, throw the error. Okay, this also I can just put it like this. Okay, now let's say, okay, so it says invalid month. Okay, month is J invalid. Make sense to everyone?
So one quick question. Apart from this, right, over here, it was a user input, so we had to convert, but is there any provision for type check? Because even I was trying to do something and I couldn't find other than converting and then catching the exception. Is there any type checks, for example, special characters or numbers or
You can say
something like that? Because
type of X equals to integer. Okay. Okay. So you can say this. All right. So this is one way to check the types. Okay. Something. Okay. So you can check this way. It is an integer, so it went there. Okay. Now it is a float. Okay. And if you say it is a bool. Okay. Am I making sense to you?
yep, okay. So basically, we don't have very structured data validations, right? Or the type validation. We'll have to actually
You will have to build
code
that.
and do it.
Yes.
Okay. Okay.
This is the right way, actually. Here, the type, if the type is this, okay, notice this. If let's say somebody entered 12 as the month, okay, what will be the type of this one? It would be a string, correct?
String.
Yes. Okay. So when the user entered the month, we took it as a string, correct? We took the month as a string because input gives us this, right? And you can actually just check the month in general. To convert the string into number, we are using the integer in case we have validated. Okay. Okay. So I hope everybody is happy. Yeah. So this is the code that we wrote just now is a very real code. Okay. Usually when you are building a business logic or you're solving problems, you have to handle the input errors. Okay. The more gracefully you do, the better it is. And soon enough, you will find when you're writing the code, soon enough, it'll keep on piling up. It'll become like a complex thing. So you might have to, create test cases. I'll talk about test cases later, and I will pick up this code again at a later point of time, right? Are you guys happy with the progress so far?
Yep.
Okay, so we have all talked about all of this. Less than equal to have not talked about. Basically, this means greater or equals. So this means if the X is greater than or equal to 5, this condition will be true if X is 5, 6, 7, 8, 9, like that. This condition will be true if X is, say, 5, 4, 3, 2, 1, 0, -1, then this second condition will be true. Okay. So if else we talked about, you can have only the if condition. Then indentation I've already talked about. Okay. So important part is in any text editor, go to preferences and go to tab settings and find out how to turn tabs into spaces. Okay. You will always have some settings somewhere. Okay. The beauty of Python code is that Python code forces you to keep the indentation. And that's, I think I love this particular feature because the code is naturally readable. The problem with any code is that code is written once, but it is read more than 1,000 times. Okay? The reading of the same, you will yourself will forget the logic of your code. Therefore, your code has to be very readable. Okay? Usually, what people usually do is they put comments in the code. By putting hash in front of it, they try to explain the code. But that should be only done in case your code is not self-explanatory. Your code must be self-explanatory. In the cases when code is not self-explanatory, only then you put comments. Why? It might look commonsensical to you that, okay, since my code is going to be read by hundreds of people, let me just write down as much comments as possible in my code so that people can read it. But reality is that if your comment is wrong, the code will run fine. Okay? But if your code is wrong, then people will catch it quickly and you'll fix it. So if comment remains wrong, you will never notice it. It'll just remain there. It won't throw any error. You won't be able to catch it. Because of which, what happens with most of the comments, that comments are left behind and they become very obsolete. Comment says something else and code is doing something else. And that's a very, very common problem you will see with the comments. Okay. So the code that you write needs to be very readable. Okay. Comments are not the solution. If somebody has to read the comments, the chances are that you have messed up big time. Your code is not self-explanatory. So as much as possible, keep your code self-readable by writing explanatory code. Python enforces indentation, because of which the code is very much readable. You can just read it very quickly. Okay. Okay. Now I'll talk about the for loops very soon. Okay. This I've talked about. 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 This I have talked about. And this I have talked about. Okay. Yes. Try except. I have just shown you that there is something called try except. Okay. Right. And basically here. So the same thing I just did, that in case the user enters something wrong, okay, and you're trying to convert it, it might throw an error. In that case, what should you do? What you should assume? That's what happens inside except. So try colon followed by a block of code and then except. Okay, what does it mean? If any error occurs in this block, it will stop the execution further and jump into except. Okay, so this is called error handling, and this is done using try except. Okay, So if any line fails inside the try block, it will jump into except. Okay. And basically, you usually do it for error handling. Okay. All right. Is everybody okay? So rewrite your pay computation to give the employee 1.5 times the hourly rate for hours worked above 40 hours. Okay. Are you guys okay?
Yes.
Will you be able to code it? This one?
Yep.
Okay.
Yep.
All right. Perfect. Perfect. Now, I want to talk about okay. I want you to code this one. Okay. I want you to code this one. Okay. This is called a Huber loss. Okay. Huber loss. What is Huber loss? The Huber loss function defines the penalty incurred by the estimation function f, Huber. Okay. If this particular difference is less than delta, what it does is it computes the mod of it, subtracts it from the delta, half of it, and so on. I'll just, let's just talk about this. So it's pretty simple. If this particular value is less than delta value, you are given the delta, okay? So let's say delta is...
Sorry, Sandeep, to cut you out, but can you explain what is this and where exactly it is being used actually? Otherwise, things are, yeah.
Okay. All right. All right. Yeah. I'll
Sorry if I interrupt your flow.
Okay. Now, I knew that. I was expecting it, and I wanted somebody to speak up. Okay.
Yeah.
I don't want people to sleep off. Okay. Good. Thank you for that. Now I'm aware that you guys are awake. Okay. So usually what happens is that in the AI, right? In AI, when we are training a model, let's say AI is nothing like when we say training a model, what are we trying to do? We are, tweaking these knobs and we are giving it an error. Okay. So we need to calculate error in anything. Okay. So the model predicts something while the actual is something else. Okay. Like, for example, the actual is 10 and model has predicted 5. Okay. So what we do? We'll say, okay, our error is how much? 10 minus 5 whole square. Okay. This is called the mean square error. Original is this much, predicted is this much. Okay. Or let me give a better example. This is actual, okay? Actual, predicted, okay? And the error is how much? The actual, okay, minus predicted whole square, okay? This is called mean error. So computation of the error is used at many places. One is to give the penalty for any model saying that, hey, error is too much. Okay. So this error is called mean squared error. Okay. We'll talk about the mean. Okay. because we are squaring the difference. Correct? So, and notice that here, if let's say our actual is 10, predicted is 15, okay? Then also the error will be. So where, if let's say we were not squaring it and we were just subtracting it, what will happen? Error will drop down. In error actual is very small and predicted is very large. So it will become a very negative number and you'll see, oh, we have reduced the error to too small, correct? Therefore, you have to come up with the function that will basically take into consideration these problems. Okay, so this is called mean squared error. Okay, so we just calculated the error. Are you guys, everybody okay? So this is the actual value, this is the predicted value, and the error is how much? Actual minus predicted. The other is called the mean absolute error. How do you do that? We compute it like this. We say, okay, if error is less than -1, less than 0, we'll say error equals negative of error. Okay, that's it. So this is called mean absolute error. Okay, absolute error. And this is called squared error. Okay, in the machine learning systems, you will notice the error computation. Is everybody okay? I mean, we'll come back to where it will be used in machine learning, but I just want to show you this, that usually we have to compare actual versus predicted. Our AI is telling that this should be the outcome, while actually something else. We have to calculate what is the error. So one of the errors is called squared error. Actual is 10, predicted is 15. So what do? Actual minus predicted whole square. That's a squared error. Absolute error is that we basically subtract. In case it is negative, we remove, we make it negative, meaning we make it positive, and that's about it. Okay, so you can actually just test it out. Okay. All right. Whether no matter what is bigger, the error is always positive. Okay. Because usually we want to minimize the error. If the error is already negative, we'll say, oh, no problem, it's all good, right? So error, if there is error, either we do the absolute error or we do the squared error, okay? Absolute error has this if-else condition. So it's basically kind of jerky, that if you plot the graph, how would the absolute or error look like? This logic that you are seeing here. It's kind of like if you see, if my actual error is on x-axis and the absolute error is on y-axis. Okay, what is the how would it look like? If error is positive, then absolute error will remain as is, nothing. Okay, so if error is 1, absolute error will be 1. So this is 1, 1, right? If error is 0.5, absolute error will remain 0.5. But if error is negative, what will happen to absolute error? It will become positive. So the curve of this absolute error will look like this. Are you guys okay? It's such a simple thing. It's just that I'm trying to plot it. So absolute error is, in case the error is negative, you basically multiply -1 with it and it becomes positive. So absolute error is always positive. Got it? So this is called absolute error. So if error is less than 0, we are saying error equals -0. Are you guys okay? No. Did I freak you
So
out?
Sandeep, yes, sir. Sandeep,
I freak.
is
Okay.
it always in the modeling one? Is it which one is better, absolute or the actual one?
We'll talk. We
Okay.
never talk about the actual error because actual error has a bug. Okay. Because in case, let's say we were doing this actual error. This is my actual error. Okay. This is my actual error. I computed actual minus predicted. Okay. Now here, right? Here, sorry. This is like error as is, actual minus predicted. Now it is minus 14. This is wrong because error is too less. It shows that, oh, we are winning, the error is too less, but it's actually error is very high. Okay, therefore nobody uses this formula for error. Okay, that's why this is essentially a wrong way of computing the error. Okay, this is not a error or a loss. It is basically difference. Okay, you might say, why actual minus predicted? Why not predicted minus actual? We are trying to find the difference between actual versus predicted, meaning how stupid is our model. We are computing that problem. Like if we are measuring the performance of ChatGPT, and there's a big difference between what it is predicting and what is actual, there has to be big error. And here we are saying, oh, error is too small, it's tiny.
But
Okay.
Sandeep, actual value, who's defining the actual value? How we are defining these number? That is also the $1 million questions.
Usually, whenever we are training any model or AI, what you do is you gather the data set. That is your actual. Then you
Right.
start training the model and it starts doing predictions. Okay. And you compare the predicted with actual, and that is called the error. Okay.
Okay.
Perfect.
But even Sandeep, just trying to understand. So for from the practicality perspective, we just gather some data and all. But how this number is coming? How are we calculating those? Maybe I'm gathering lot of string or lot of names, and then we have to be trained some model. How many time Ranbir is coming or something. We already talked about. So how we are coming with those number also then?
Yeah. No, those things are important, right? Like, for example, in case of ChatGPT, they hired many experts to write answers. So that correct answer is considered as the de facto standard. Okay. And the model is supposed to do like that. Okay. Or let me say this way. Let's say there is a factory and we are saying that the system needs to predict this output, like some sort of model we are creating that, okay, to predict the outcome of the particular process, we have designed some sort of logic and we are trying to figure out how much errorness is this model. Okay. Any tool that we're building, it is producing something and we want to compare how good it is. Okay. We have to compare it with actual, right? Now, when we are comparing it, we will say that, okay, right? So we will always compute the difference, which is absolute difference. Let's say something is like you gave an exercise to your son, he gave this outcome, but actual value was this much. So this much is the error. Okay. This much is that. So always we take into consideration this gap. Okay. Whether he predicted it more or he predicted it less, we always consider the difference. Absolute difference, right? Not just the difference. Because when you consider just the difference, a problem is who should be subtracted to and who should be first and second, actual or predicted, right? Therefore, it's always whenever we're computing the error, we have to figure out a formula or figure out a logic which will take into consideration that that whether I'm predicting too small or too big, it's all the same. It's all basically a mistake, right? You got my problem? No?
Sandeep, that I got it, but still, just trying to, scratch my head. Even right now, we are assigning a value in a numeric, right? So actual is equal to 100, predict is equal to 1500, which is fine. But in actual or in a practical way, the example which you are also giving, like in a factory, we be just trying to create a model and then preaching that model and all. How we going to get this number? Is there any threshold, or is there any kind of standard in our AI or anything where we can?
I'll talk about the cases where you have text as the outcome or image as the outcome.
Okay.
Right? Here I'm talking about a very extremely simplistic thing.
Right.
That your model is predicting a number. Now, who is giving the actual? Basically, we have taken the historical data. Let's say you are predicting the stock price. Okay, stock price 100 is the actual, and your model is predicting 1500. How much is the error? 1400, right? It's not minus 1400, it's 1400 is the error. Okay, so that's how it is, right? So you always, let's say you're building a stock prediction model, what will you do? You will gather the historic data that, okay, when yesterday one day previously, this one was the stock, the next day was this much. So previous day, the stock value is the input to the model. And what is model producing? Model is producing next day the stock price. Correct?
Right.
Based on previous days data, news, everything combined together, you want to build a model which will predict the stock price tomorrow. Okay, so how would you test such kind of model? You will pick up the historic data and run it on the history and check how much error it has caused. Okay, in those cases, you cannot use this formula straight away, because let's say first day it made a mistake of 5, other day it made a mistake of -5, both of them canceled, and then you say, oh, all of this is 0, so my model is working perfectly fine, right? Therefore, you always come up with a better formula. One of them is using absolute error, meaning in case the error is negative, just remove the negative sign. Okay, by putting minus in front of it. So absolute error. Second one is you put actual minus predicted whole squared. Okay. Now, there are so many formulas and so many people keep on coming up with so many formulas to solve this. And one of the formula is called Huber laws. Okay. Huber laws is something between mean squared error and absolute error. Okay, so if the error is less than delta, what you do, you square the error and divide by 2. Okay, delta is some number, let's say delta is 0.5. Okay, and otherwise what you do, you multiply, usually we keep delta as 0.5 or let's say 0.8. Okay, so if the absolute value of error is less than equal to 0.5, then your overall error is square by 2. Otherwise, you multiply by delta. Delta is 0.5, say, multiplied with absolute error minus delta by 2. Okay?
And Sandeep, why do we keep the delta is 0.5? Means, isn't it, means if the error, suppose we are talking about the range of 1000 or something,
yeah,
and then we keep delta is 0.5, isn't it too less?
No, in case it is greater than 0.5, then this formula. Okay. Yeah. All right. In that case, this formula apply this one. So somebody like Huber came up with a better loss function. Okay. So let's try to see if we can, let's say, code it. Who will help me? Okay, let's say, who will help me? Okay, instead of A is equal to actual minus predicted. Okay. All right. Let's say this is 110. Okay, so A is the error. Okay, now we are saying the first condition. Okay, who will help me? Can anybody help me? If, okay. The thing that we did here, it's also can be done easily using the something called absolute function, but we'll code our own function. Okay, so absolute value of A, okay, we will calculate, let's say AB. This is A, and we are saying if A is less than 0, then my absolute value of A is equal to minus A. Otherwise, absolute value of A is equal to A. Is this logic okay to find the absolute value? So ABS absolute error is basically this. Are you guys okay? Or I can also do this simply. I can basically reduce the code a little bit. I can also see. Yes. So I calculated the absolute error because I need that absolute error again and again. Okay. Now, who will help me? So I calculated, right? So this is my error. I calculated the difference. Okay. First, I calculated the difference. Right now, just don't think about like where did this formula come up from. Let's just try to convert this thought into code. One scientist, Huber, came up with this thought that if, right, if absolute value of A is less than delta, then error is this much, otherwise error is this much. Okay. So let's see. Now, how much, let's say this delta, I am going to define it as 0.5. Okay. Now, if now let's code this function. So we calculated absolute, we defined delta, we defined A. Now time has come to write this. Anybody? Shubodh, anybody? This logic says if A is lesser than equal to delta, then the error is half of square of A. Otherwise, delta multiplied with absolute value minus delta by 2. Okay. I mean, see, the thing is that the one fear I want to remove from all of your mind is that this thing is actually pretty simple. Just because of these symbols, it looks so complex. Just because of these symbols and this and that. But it's actually pretty simple. Like absolute thing is pretty clear, right? If something is negative, just turn it into positive. End of the story. And here you see these two vertical lines. That means absolute value. This is essentially the absolute value. Okay. This is essentially the absolute value. This thing that you see here. Okay. That's basically absolute value. Absolute means positive value. Minus 5's absolute value is 5. Minus 10's absolute value is 10. And 10's absolute value is 10. Or 20's absolute value is 20. So this is absolute value. Okay. Yeah. So Subodh says if absolute A is less than equal to delta. Okay. All right. Yeah. Thank you, Samir. Thank you.
Yeah.
Subodh.
So yeah,
Go
absolute
ahead.
error.
Absolute value A is less than delta, then let's call it, the outcome is
Error.
called Huber
Absolute error.
loss. Okay, we'll just call it
Hmm.
Huber loss. Initially, we're just putting 0 into it. Okay, so we are saying, you are saying, or just call it Huber. That's easier. Okay, Huber equals A square by 2.
2.
Yes, as
Yes.
Huber equals
Delta
delta
into brackets.
Absolute square,
So,
absolute, minus
minus
1
delta divided by 2.
correct.
Hmm.
That's about it. And there we go. Okay. Cool. So if I'm saying that this is 100.4, then it'll be like this, otherwise it'll be more. That's it. And remember how we defined that graph? Okay. So if you take a look at the graph of this one, the graph of this one, absolute error, this is absolute error, right? The graph of this one looked like, how did it look like? It looked like this, correct? Whatever is the actual value, we basically let it be as is, okay? And let me just correct it. Okay, so this was absolute error, right? And the squared error, how was it? It was like this, okay? And in case of the Huber error, it was like some form. Okay, we'll talk about that. That's not important right now. But the great part is you are able to code Huber loss. Okay. Huber loss is one that is used in even while training ChatGPT at multiple points. You will study further, but it's a part of the game. Okay, so this would happen a lot in my classes. That's something that you're supposed to study later. You will study in the beginning. Does it look complex to you?
No.
I'm very happy that some of you are actually able to code it up with me. Yeah, go ahead.
Sandeep, why are we defining Hoover is equal to 0 before the calculation?
Good question. We don't need to. You don't need to. It's just a good habit to just define it upfront.
Sandeep, but what is the value which we tend to go to? It would be 0 only, right? I mean, if it is 0, that means the predicted values are as good as actual.
Yes, yes. But right now, we don't care about that. We are just defining a way to evaluate the difference between actual and predicted. Okay?
Okay.
Yeah. So overall, we would like our model or whatever our system we are designing, that there should be as minimum as possible different like error as we can make. Like when we are playing game, we want to minimize the loss, right? Similarly, here also we will minimize the loss that we'll study in the future when we are learning machine learning. But right now we're just learning to code things up. So this is a good exercise that given a mathematical function can be coded. Are you guys okay?
Yep.
Good. Okay. All right. And I feel that this is a good start. We will convert these things into functions when we study functions. Okay. So we learned two things here. One is Huber loss, absolute error, and other is the squared error. In case of square, basically we just square it. This squared error is something that is used in almost every situation, computer vision, everything, every AI, we basically use the squared error mostly. This is something that we have started using lately, and we are seeing a lot of success in this. But I still am a person who likes the squared error, okay? Because that's super simple to do.
So Sandeep, a quick question I have. That delta thing, who defines that delta? Who validates that delta?
Good question. Good question. So delta is something that people do, lots of scientists that you meet and they keep on publishing paper. What they do is when you are building a model, delta they keep on brute force and keep on trying.
So it's a learning kind of thing, right?
Yeah. Yeah.
So
Yes.
let's say we have a problem for which we are trying to train our model in AI. And let's say you have 15 scientists from the same area. But
yes,
somehow those 15 scientists have different opinion about the delta. Then
yes.
how we reach to a common consensus? Is there any way?
The backfill, no? You basically test which one is making more sense, which one is giving better results. On large data, you have hundreds of kind of data. So basically, this loss that we are computing, it is to basically, beat up the model, right? The computer will basically observe this error and beat up the model until this error keeps on minimizing. Once that is done, then we'll observe that which of these scientists' model is giving better results on the backfill of data, like the older data. Like if somebody comes to you, like if let's say somebody comes to you and tells you, hey, I have got this brilliant ability to predict your future, what will you do? You will ask him about your past, right? Similarly, when some model is trained, what we always do, we take basically, we give it some data that it has not seen and check whether this model actually is capable of doing things or not. Okay, so that's a general thumb rule. There is in case of science, in case of AI, in case of machine learning, it doesn't matter which scientist came up with a better idea. Okay, which scientist came up with the idea. For example, there is no proof by authority. Okay, like for example, the people who got the Nobel Award in computing, Nobel Award is called Turing Award in computing. So the people who got Turing Award, next month, after they got the Turing Award, next month they published their model, and some people tested it on different data sets. And they said, hey, your model doesn't really work. It just worked on your data set. And their paper, the people who got the Nobel Prize, like Turing Award, their paper got rejected. So in case of AI, the only truth is data, historical data. Okay? That's the ground truth. We call it gold data, we call it the actual data. And so, does that answer your question?
Yeah, definitely. I mean, maybe I have a follow-up question as well. So it also depends on the type of systems like mission critical applications, medical systems. There is no scope of delta, right? You need to be very, very accurate.
Basically, the purpose is to be accurate, but how to be accurate? Okay, like for example, there are lots of issue about this. It's like if you want to pet a dog, you want to keep a dog in your house, how would you trust it? Can you leave the dog near your baby? Right? It has to be well tested in the history. And you should know exactly how good it is, right? So the same thing applies to the machine learning models. You test on different kind of circumstances. And any system, even when you're coding system and you're sending it to satellite, you test. Okay. And that's how it is. And most of the time, the systems that are tested on large data set as compared to the normal coded systems, the one that has worked on large data set well, they are more reliable. Okay. So there's no other.
Sandeep, sorry. So Sandeep, so the value of the work of delta in this function or the Hoover laws is to sort of have a limit till which error we should consider, and rest all should be treated as outliers, right? It is just helping us to gauge or limit our analysis, isn't it? I mean, based on how it is looking at, because anything which is less than delta is taken exponentially, right? Rest all is sort of okay, man. I mean, is that reading correct, or how is it?
No, I think it's good to have the interpretation, and we will talk about its interpretation later. It is
Okay.
It is basically designed from the perspective that from the perspective of the algorithm that is used to train machine learning module. For that particular algorithm, when the error is too small, then dividing it square by half makes more sense. When the error is too high, then squaring doesn't make sense. Okay, squaring just explodes it to very high value, and that's why instead of squaring, you use absolute error. Okay, or you can say this way, the problem with absolute error was that this was like too much of, see what was happening in case of absolute error. Let's take a look. Okay, let's take a look at the absolute error. Okay, right? On the positive side here, what is the slope of this line? Positive, correct? On the negative side, what's the slope on the negative side? -1. You see that? Now, on this side of the origin, the slope is negative. On this side of the origin, slope is positive. What is the slope at origin? -1 or +1? So there is a stupidity there, right? That there is on origin, we don't know whether the slope of this line is negative or positive, correct? Therefore, what they did, they said, okay, we will do something, okay? Near the origin here, we will make it rounder, okay? So that's what they did. That's what this one did, that, okay, near the origin, what we will do, we will basically say that, okay, here, we'll make it look like the squared error. Like, how does the squared error look like? Squared error look like this, correct? For it'll be 1, for 2 it'll be 4, for 3 it'll be 9, correct? So near the origin, we'll basically make it a squared, like when it's tiny near the 0, and for rest of it, it is like absolute error. Got it? So
Okay.
this kind of because squared error is squaring it, right? Squared error looks like, how does the squared error looks like? Okay, for 1 it is 1, for 2 it's 4, right? This is another point. For 3 it's 9, correct? So the squared error looks like this, right? And basically that was basically this is good because here the slope is all okay and all works fine, right? So the only problem is they just explodes too much and so on. So they took absolute, and they got a absolute, and then they got a squared error, and they merged it together, and that's what became the Hoover laws. Okay.
Okay.
So I think that's a better interpretation. We'll talk about this, don't worry. But here I just wanted to get you started on thinking in terms of that those who are already familiar with Python, they should go, they should also get to learn something more along with everybody else. Okay, so that's why I want to, all the exercises that I'll be doing, it will include both, like a lot of machine learning concepts and a lot of AI and data structure concepts. So most of the exercises that you see would be like that. Okay, so yeah, those who are comfortable with coding, you can take a problem today. Right? Go through something called BLEU score and code it. Okay? As a homework. Or I'll describe those things more as we go ahead. Okay? It's a good, very good exercise. I can guarantee that part. Okay?
We
The
have
more
to send this coded assignment to you, Sandeep. Email
Yeah.
it to you, or
yeah, email it to me. Okay, reach us at CloudxLab and I'll take a look at that.
okay.
Okay, now, okay, everybody okay with this so far? Let's move on. And where is the Python one? Okay. Okay, this I can remove. Okay, this I can close. Yes. Perfect. We are doing very good. Now, most important thing for everyone. Okay, most important thing for everyone. These two chapters are really critical. Okay, and I would like everybody to pay closer attention. Okay, I want to do it really quickly, and I would code as we talk. Okay, so functions are very, very powerful. Okay, functions are very powerful. Instead of, functions are like creating machines. Okay, like for example, we wanted to, we created all of this, but if you have to reuse it, it becomes a painful thing. So what we can do is we can take this, okay, and define a function, define Uber laws, okay, and we give it, okay, we basically just take this code, we take this code and put into this. All right, we take this code, we put into this. Okay, notice that the signature of the function, define, this is the name of your function. Okay, this is the name of function, just like print is the name of the print function, you have created your own function. Okay, so we are creating our own function, which when we run this Uber laws, it will run all of the instructions inside it, right? So we can basically say Uber laws, and it gives this answer, right? If we have to modify it, we can modify the code, okay, and run it again, okay? But a better idea is that we basically think of the Uber laws as a machinery. Think of a function like a machinery where you give the input to it and it gives you the output. And how do you give the input to a function? By passing them as argument. So you can move these things, okay? You can move these things actual as one argument, predicted as another argument. And instead of hard-coded value like this, we can pass them as the argument. So we have just defined a function Uber laws, which takes two parameters, actual and predicted. Okay. And it prints the difference between them. So we can reuse it quickly. We can just feed it some other number. We can feed it some other number, and we can basically do that. Are you seeing this? Are you guys okay?
Yes.
So
So
we just
Sandeep,
find,
yeah, sorry, a quick thing. So does Python support overloading
I'll talk
kind
about
of thing?
I'll talk
Like what Java does?
I'll talk about It's way better than that. Okay, you will enjoy this. Okay, I'll share this notebook, definitely. Okay. All right. Is it good? So we just created our own machinery. It took the input from us. Then when I call, so here we are defining the function. It's like creating a machinery. We are not running the machinery right now. So we defined a machinery called Huber laws, which takes, or you can think of Huber laws as a tool that will do the Huber laws for you whenever you call it. It's not running right now. We are just defining it. We are saying, take one variable called actual, other called predicted, and then compute A equals to actual minus predicted, and then delta is this, and so on, right? And there we have our own function. Okay, perfect. And this is good. Right? Would you like to pass delta as one of the arguments, right? Let's say we put delta as the third argument, okay? And we want to say that in case nobody specifies, delta, okay, set the default value as 0.5, okay? So again, now, if you don't specify the value of delta, it will be taken as 0.5. If you specify the value of delta as 0.3, it will be taken as 0.3. So what is happening? Whatever you are entering from here, right? When you call this, this is called calling the function. This is called defining the function. So it is doing some magic inside it, okay? It's taking actual. So you can think of Huber laws as a machinery, okay? We just created Huber laws underscore laws. It takes predicted, actual, and it is also taking delta, and it is printing on the screen point, printing the actual value, right? So then it's printing the loss, correct? So you can think of this as a machine that it takes predicted, actual, and delta as the input, and it prints something. And this delta is an optional argument. If you don't provide it, if you don't provide the data, if you only provide actual and predicted, it will assume it to be 0.5. The default value of that one is 0.5. Are you guys with me so far?
So only for the default argument, it should be at the end, right?
Correct. Otherwise, you'll be get confused which one to feed. Okay. You cannot have things like if you put delta here in the midway, you'll get confused. Okay. All right. As well as a very important part that there can be more than one value of these things. Okay. So more value of these optional parameters. Okay. So if let's say predicted was also say, and you can have, let's say, change the order of these. Okay. Change only the order when it's needed. Okay. Don't change the order just like that, because people are expecting a certain sequence of things. Okay. So here, when there is no loss, okay. Now you see, predicted, actual, and this. Let's say you are saying actual. If nobody provides actual, consider it like this. Okay. So what will happen if you provide one value? This is predicted, actual is 4. Okay. When you provide two values, this becomes predicted, this becomes actual, and delta is 0.5. Okay, makes sense to you? I'll remove this. This is okay. So you can
Is
have.
there a way? Yes. Is there a way where you can specify that we are passing the, like only two arguments, but not in that order? Because
So we'll
over
talk.
here, if we just provide one argument,
yeah,
then two will be assumed, right? Like if actual is also defined with some default value.
Yes. Yes. So what you can do is you have something called keyword arguments. We'll talk about keyword arguments soon.
Okay.
Okay. Okay. I think you can do this. Let me see if I can. Okay. Does it work like this? Yeah. So you can have things like this in Python. You can actually specify what you are setting.
Set. Okay. Great.
Okay. Okay. So you can actually say explicitly also in Python. If you are not clear which argument is getting into which one and which one is default, just pass in the actual variable name and pass their, values like this. Okay. This is pretty useful. It is very, very intuitive as well. Okay, so does it make sense? Okay, who will
So,
help?
Kamleep, do we have any support of variable arguments like in C++ and
Yes.
couple of other languages? We have a support of variable arguments as well, right? By using 3 dots.
Yes. Variable arguments, we have keyword arguments, we have lots of things. Okay, you can convert an array into an argument and back and forth. Okay, very powerful. Honestly, after coming from Java, I actually love Python's way of dealing with things. If I have to build a language, I'll build a language like Python. Initially, I was finding it very awkward. Why do I have to put tab and all? But once I understood that this actually makes sense. Okay. A question from Subodh is, do we have pass by reference? I'll talk about that. Okay. Perfect. Let's talk about return values. Return values are pretty important, right? Now, let's say I want to do a function that okay. All right. I'll just stop at the return value and then we'll carry on from there. I want to spend good time on functions. Okay. Now, okay. Let's say what you want to do is you want to say loss equals Uber loss. Okay. Instead of printing, you want to put it into a variable. Okay. But this loss is not coming out. It is still undefined. You see, it is empty. By default, variables are assigned a value called none. None means empty. Okay. None means empty. Okay. None means it doesn't exist. The value doesn't exist yet. Okay. So none represents that we have not assigned any value to something. Okay. So right now, what is happening is I want to, whatever is Huber loss coming from this calculation, I want to put it into a variable. I don't want to print it on the screen. I want to put it on the variable, right? Here, it's only printing to the screen. It's not putting into the variable. This is still, you can see that it is still, loss is not being printed. If I say loss into 12, it is throwing error. That's basically empty. So what do? This is where the return value comes into play. Okay. To solve this problem, what I do, I would say, instead of printing onto the screen, okay, I want print onto the screen, and I'll say return it to the caller. Whoever called this function will get it returned. So here, now you see this loss function, basically what happened? We called the Huber loss. We called this function that we just defined with two values, predicted and actual, and then it gave us what? It gave us the whole thing after computation. Okay, this is called return value. As soon as you return, the execution of the function stops and it returns whatever it has calculated so far. Okay, is everybody making sense? Is everybody okay with this? Not everybody making sense. Okay.
Yes.
All right. So we talked about functions. Now, coolest part about the functions. Okay. Coolest part about the functions. Function can call themselves. Okay. Function can call themselves. And this is a most powerful technique that you will see in computing. Okay. I want to just complete this thought process. It is called recursion. Okay. Recursion. What is a recursion? Recursion is a function calling itself. Okay. And I want you to think about it. Okay. I want you to think about it. That imagine that we want to compute something called a factorial. Okay. What is factorial? Factorial is, right? Factorial, let's say 4 factorial. Factorial of 4 is equal to 4 multiplied by 3 multiplied by 2 multiplied by 1. Factorial of 5 is what? 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So you can see factorial of 5 is equal to 5 times factorial of 4, correct? And factorial of 4 is what? 4 times factorial of 3, correct? And factorial of 3 is how much? Is equal to factorial of 3 into 2 into 1, which is same as 3 multiplied by factorial of 3, correct? Are you guys okay with me? Factorial of 2 is equal to 2 into 1, which is same as 2 into factorial of 1. And factorial of 1 is equal to 1. Okay. So we only have to calculate the factorial of 1, and we can calculate factorial of any number. Okay. Let's see. Let's see that. Can we do that? Let's say we are defining a function called factorial, and we are passing n to it. Okay. And we are saying if n is 1, return 1, else return
and into factorial and minus 1.
And it just works like charm. Factorial of 1 is this. Perfect. Factorial of 2 is 2. Factorial of 3 is 3 times 2, 6. Factorial of 4 is 24. and factorial of 5 is 120. Am I making sense?
Yes.
Okay. So as a homework, I want you to design multiply. Okay. You multiply x and y. These are two integer numbers. Okay. Integers, x and y integers. Multiply x and y without using asterisks. Okay. Don't use multiplication. Just use the addition. What is multiplication when you multiply x and y? Okay.
Plus
You
plus
add x, y times.
Yes. So without using loop, without using asterisk, can you do the multiplication?
Without using loop.
Without using loop.
So basically, we have to use recursion to do it.
Yes. Think over it, and we will catch up next week. Okay?
Hey, Sandeep, so far in today's lecture, we had 5 assignment of 5 programming questions. Is it a way, are all of them in this notebook, or is there a way we can get a list so that, you know?
Yeah. See, yeah, I'll just share it right away. Okay. I want you to go through this notebook and then, okay. And I'm going to just share it with everybody. Don't worry, stack. Sameep, about the stack. Okay. Just think about it. Okay. And yeah, I want you honestly to, I want everyone to honestly give it a try. Okay. Is this the one?
There are only 2 assignments, right? One is this BLEU score, and
So
the
the
second is this multiply.
no, the first one was
I'll have to figure out. I don't
maybe I'll summarize. The first one was that the string one. The second one was, I think, to do again the commission one, and then Huber loss,
String
and
one, what
then
is the string
BLU,
one?
and then
Yes, Subodh. What is the string one?
the take a list of, I think the first one, yeah.
This first question I gave was something that you can think, so you should think over the week. Those who are already comfortable with coding, those who are not comfortable with coding, they should think over it, because one very important thing I want to convey is that even though things are very obvious to the common person that, okay, this is something anybody can do, but it's pretty hard to code. Okay. So this is a kind of a challenge question. Okay. And go through this notebook and right. And try solving questions. Probably code this one by yourself, code this one by yourself, this one also by yourself without looking at the notebook. And right, the next question was here, the blue score. I had put in blue score somewhere, right? Okay, I had not put in blue score. Yeah, here. This is the problem statement. Okay. Blue score, study the blue score and code it. Okay. And yeah, I would say that as exercise for the week, other than what is there in the LMS, LMS has its own exercise other than what's there. My request to all of you would be to at least to just go through this notebook, try code up all these things by yourself. And yeah, and this is another challenge. Okay, this is another challenge that you should try doing. Okay. All right, I will share this notebook with everybody on the WhatsApp group as well. I have shared. Okay, so thank you everyone. I look forward to see you next week. Okay, and
Thanks.
oh, I only shared the
Thanks.
file with one person. I'll just share it with everybody. Okay, so yeah, do code these things and we will work it out. Okay, and yeah, and start right just after the loops. I would like to have a very wonderful exercise sessions with all of you. You should just after the loop you should start attacking the problems. You should start working with the problems, and then we will learn as we go. Okay, all of us. I'm yeah, I'm requesting everybody to start participating into coding things. Okay, just go through whatever we did today, code it up without seeing my solutions. You know the problem statement and do that. Okay, it's very important. To you, it might look like that it's easy, but when you don't look at my code and write your own, you will struggle for it. Okay, like try doing leap year challenge, try doing the Huber code, try coding up these things one thing at a time. Try writing factorial, try writing these things. Okay.
And we have to
And
email it to this reaches at CloudxLab.
yes, yes. Okay. Yeah. All right. Perfect. And come up with more questions and we will have meet up next week. And yes, this is going to be unsettling for all, but this is the time that will push you out of your comfort zone. So spend your time coding it up, going through the notebook, writing your own solutions. And this is the time to get out of comfort zone. Okay. Bye-bye. Have a good day.
Thanks, Indeed.
Bye. Thanks. Thanks, Sandeep. Thanks, everyone.